Greetings. This video presents a conjecture about quantum reality. In physics, such a speculation might be called an interpretation. This conjecture is not a theory. I want that to be clear. Theories have mathematical evidence. For example, quantum mechanics yields predictions which have been rigorously tested in a broad range of experiments. Not one prediction from quantum mechanics is found to be contradicted by experiments. Yet, there are a surprising number of contending schools of thought over the interpretation of quantum mechanics. Most students of physics have heard the old saw, quote, don't interpret, just compute, end quote, or just calculate sometimes. Wikipedia, a source dismissed by many scientists, indicates that there are about 17 different scientifically credible or mainstream interpretations. They go by such names as the Copenhagen interpretation, the many worlds interpretation, etc., along with a fair number of unorthodox interpretations. The one you're about to hear is one of these unorthodox interpretations. Richard Feynman, the noted physicist, recalls that there are these different theoretical representations all describe exactly the same physics and are all mathematically equivalent. Feynman said, quote, I think I can safely say that nobody understands quantum mechanics, end quote. Essentially what he was saying was the math works, the interpretations, are up in the air. My position is that nothing in this conjecture disagrees with the math. I think you may find the conjecture interesting, if only because it deals with many of the mysteries which modern physicists don't fully understand. Specifically, I will discuss the following. Let me hold them up here so you can see. I'm not going to read them off for you, but I'll check them off as we go along. Okay, well, I will read them off for you. The origin of the universe, the Big Bang, the nature of space-time, quantum fluctuation, the idea of mass, and the Higgs boson, gravity and gravitational waves, the fundamental particles, that is, which particles are really fundamental, neutrino oscillation, the expanding accelerating universe, baryon asymmetry, time asymmetry, the inflation at the beginning of the universe, or the so-called inflation, magnetism, quantum entanglement, black holes, some speculation on the creation of supermassive black holes, and a word or two on quantum wave theory. I'll also touch on other ideas, but these are the ones you should be most critical about. Let's begin with the Big Bang. Many people are familiar with the notion that the universe was contained in a singularity, a point far smaller than a tiny atom, containing all the matter, all the stars, all the galaxies, everything in the universe, and that this singularity exploded in a Big Bang, releasing the universe in spectacular fashion. Not long ago, I wrote to Don Lincoln at Fermilab, who replied as follows, quote, no serious scientist truly believes that the Big Bang started with a literal singularity. It's well understood that quantum gravity will result in something different than a naive view of general relativity. But that's it. He didn't expand on what that something different might be. As it happens, as far as I can tell, no one has a truly convincing theory about the origins of the universe. A lot of people have a lot of different theories. But this is a magical moment in history when my notion is as good as anyone's. Consequently, I composed this unique conjecture about what happened at the Big Bang. The idea is based on motion, and I underline that word motion because it's all about motion. So let's begin. Let us suppose there is a single point, a singularity, if you like, of dimensionless space, a here with no there. In other words, a point of space with no dimensions. This singularity contains absolutely nothing except the quality of motion. Singularity contains no universe, no mass, no matter, just the limitless quality of motion, limitless motion. This point of dimensionless space, which we'll call pure space, is surrounded by an infinite sea of static time. Let's call that pure time. This is time without motion. There is no forward time, no future, no backward time, no past. There is only a static, immobile now. The action, that is the Big Bang, happens when pure space mixes with pure time, creating modules of space-time, such that motion is imparted to time, to pure time, which was static, is now set in motion, and multiple dimensions are evolved by the space-time modules, which result, generating an extraordinarily rich variety of space-time configurations, which we'll call the here and now. This abrupt, spectacular, and undoubtedly violent creation of these space-time modules is an instantaneous chain reaction precipitating space-time in every possible configuration of space bounded by time. There's your Big Bang. So we'll check off number one. Let me get it right. Big Bang. Now, this action is instantaneous everywhere because until the creation of space-time, pure time is exclusively in the now mode. So this idea of inflation for some small amount of time at the beginning of the Big Bang, I don't believe it really happened. I believe it was instantaneous. There was no amount of time for this inflation to occur. It happened infinitely everywhere because pure time was in the now mode until the Big Bang. Now, most of the configurations of space-time that were initiated decayed virtually instantly into less complex modules until the least possible unit of space bounded by time evolved, becoming primary space-time, such as that thought to be existing throughout the universe in the void between the galaxies. I suggest that everything in the universe, including what we think of as empty space between the stars, is simply some distinct configuration of this primary space-time. To avoid any misunderstanding, I mean quite literally that everything, from the tiniest imaginable particle to the largest structure in the universe to the entire universe itself, is composed solely and exclusively of space-time in some configuration or other with different degrees of motion. So, check off the nature of space-time. Now, pure time resists mixing with pure space, but pure time is captured by the motion associated with pure space and cannot shed that motion. Hence, pure time tends to spread motion to the lowest achievable unit of space-time, that is primary space-time. This primary space-time would have a granular characteristic. Primary space-time creates a pressure field that resists displacement by other forms of space-time, which we will call secondary space-time. Primary space-time exerts pressure against secondary space-time. Entropy is the process of pure time breaking space-time into the smallest, least intrusive primary space-time configuration, consistent with the local time momentum. Pure space continues to impart movement to pure time, even at the primary space-time level. However, and this is important, not all configurations of space-time decay into primary space-time. Some forms of secondary space-time are more or less durable, with varying decay rates as measured by the motion of time. We will label these durable configurations matter. In this context, matter is what can be detected by science, that is, anything that is not primary space-time. The standard model indicates that matter consists of 17 or 25 if you, depending on how you count the vector bosons, but 17 distinct non-decomposable particles. However, For the purpose of this conjecture, there are merely four fundamental, non-decomposable secondary space-time particles. These are the photon, the neutrino, the electron, and the proton. Each of these four fundamentals is viewed as a different, localized motion configuration of primary spacetime. Here's a concept. Each of these four fundamentals is a soliton moving through the space-time field. Simply put, a soliton is a solitary wave that propagates with little loss of energy and retains its shape and speed. An example we all know of is a tsunami, which is a gigantic soliton, moves through the ocean hundreds of miles. At the opposite end of that spectrum, where a tsunami is huge, the four distinct durable quantum fundamental particles are solitons. Solitons are waves that are stable and can travel over very large distances, retaining their shape and outer envelope. Now, some amount of primary spacetime units form the soliton. They might produce a photon, or an electron, or a neutrino, or a proton, moving through a sea of primary spacetime. So that takes care of number 6, which is what the fundamental particles are, at least what I think they are. Now, in this conjecture, quarks and other leptons and bosons are legitimate mathematical constructions. And as quarks and leptons and bosons are descriptions of localized primary space-time motion with limited durations in many cases before they decompose, or in the case of up and down quarks, coalesce, often through complex quantum mechanical steps into photons, neutrinos, electrons, or protons, or combinations thereof. Of course, the proton does not fit this description comfortably because it is not considered fundamental. However, the quarks within and the energy surrounding the proton might be viewed as complex motion within the soliton envelope. However, outside a protective electron shield, naked protons or ions are rarely encountered, and naked quarks are never found. So, is it possible that the universe is merely space-time in different motion configurations? Swirls in the primary space-time sea? Consider this analogy. We have all experienced water in 3 distinct phases: gas, liquid, solid, each with different degrees of motion. Yet within each of these 3 phases, water presents itself in a wide variety of forms. For instance, when water presents as a gas, we have humidity, clouds, fog, steam, mist, etc. You know all the names. In a liquid phase, we have dew, rain, ponds, rivers, waterfalls, oceans, etc. In solid, we have snow, frost, ice cubes, ice caps, icebergs, and on and on. These and many other terms are applied to describe distinct forms of water presentation. We have literally scores of different terms for water in different forms of presentation. It is conceivable that diverse configurations of secondary spacetime present differently and therefore appear to be unique and distinct. That is, subatomic particles, atoms, molecules, combinations, rocks, plants, animals, planets, etc. Now, here are additional thoughts on how, as part of this conjecture, particles of matter and forces are created from space-time configurations. First, I should acknowledge that in the Standard Model, the current benchmark of physics, there are recognized 12 fermionic fields, 4 electroweak vector boson fields, 8 gluonic fields, and the Higgs scalar field. I have no quarrel with any of these concepts as mathematical conveniences. I mean, they're reality, but they're reality mathematically. They're not reality in an interpretation. In an interpretation, I think they all operate in the context of a single primary space-time field. That's number 15. Took care of quantum wave theory. There you go. Let's see if I missed any. No, I think that's it. Okay, moving along. Virtually all secondary space-time configurations or particles are deemed to have a characteristic called mass. Mass is generated as secondary configurations move through or disturb the primary space-time field, altering or changing the motion of pure time surrounding pure space at the primary space-time level. Rather than being mediated by the exchange of a boson, kind of a mysterious concept, mass may be the interaction, roughly analogous to friction, of a secondary surface or contour moving within the primary pressure field. Soliton moving through the primary pressure field. Mass indicates some elevated displacement of surrounding primary spacetime well above that of a photon. Photons are said to have no mass. So that takes care of mass in the Higgs. Primary spacetime surrounds all secondary modules and is incorporated within all of them, obviously. Various secondary configurations can join together to create elements with discrete mass, provided there is sufficient motion to draw off some intervening primary spacetime via the transfer of that motion to that intervening spacetime, eventually creating photons or electrons or neutrinos, which are emitted. The more complex secondary spacetime created by this process displaces more primary spacetime than would be displaced by the unjoined secondary elements, creating a significantly amplified primary field pressure around the newly created secondary element. In other words, you take two, you put them together, it gets bigger, and it displaces more primary spacetime, holds them together. All particles and elements are surrounded by the primary pressure field generated by this displacement of primary spacetime. Depending on relative motion and proximity, distinct secondary pieces can be forced together, but not atomically combined, at least not at first, when their primary fields combine. Similar to adjacent water droplets combining when they touch. We've all seen that. This effect I would call gravity. It reduces the primary displacement by creating photons, but not neutrinos or electrons. Let's discuss gravity now. The following part of this conjecture describes gravity not as an attractive force generated by matter, but as a repulsive force generated by primary spacetime. For those who find it difficult to imagine gravity as the force of surrounding primary spacetime pushing secondary spacetime together, rather than some kind of invisible field reaching out and sucking things towards it, think about a glass of seltzer water or beer. Tiny bubbles form at the bottom of the glass. As they rise, these bubbles grow because the heavier water molecules force the lighter gas molecules into a sphere. When this process takes place on a large scale, for example, the sun, it creates a chain reaction of photon, electron, neutron production, and the creation of more secondary spacetime. That is the heavy elements. So at first, gravity just holds them together, but as it increases, it will atomically combine them. Is it conceivable that certain secondary configurations are durable but not detectable because they do not interact with ordinary matter, and therefore are not ordinary matter? These configurations may react with, that is, displace primary spacetime and be subject to spacetime compression, and maybe dark matter or dark energy. That doesn't have a place in this conjecture at the moment. I'm still thinking that out. Let's talk for a moment about entanglement. All pure time is completely entangled, even in space-time configuration. What happens in pure time happens instantly throughout the universe. Consequently, this may be what Einstein called spooky action at a distance. If two particles of matter can be manipulated so that they share the same pure time within their space-time envelope, they are entangled. Let me put it another way. If the pure time element or portion of the space-time envelope around one particle can be synchronized with that of an identical particle, it follows that whatever affects one particle will instantly affect the other regardless of distance, because the pure time element is always in the now model, as previously suggested. That's number 13. Quantum entanglement. Now, what we call space in terms of space-time is three-dimensional. What I'm talking about is the space that we experience, back and forth, side to side, up and down. Is it possible that time is also multidimensional? What might be the implications of that? Well, for one, antimatter. What if antimatter is secondary spacetime with motion imparted to pure time at the Big Bang in a direction opposite to that imparted to what we call matter? Okay, so at the Big Bang, matter goes this way, antimatter goes that way. This is not an original thought. Richard Feynman and others have wondered about this possibility. One wonders if this assertion about the differences between matter and antimatter might be useful in verifying or debunking this entire conjecture. At the Big Bang, motion might have been imparted to pure time in more than one direction, resulting in space-time moving into a multitude of pure time dimensions other than our own. Moreover, if pure time could move in more than two directions when commingling with space, might this characteristic admit of the ostensible multiverse concept? Might there be multiple, simultaneous, possibly infinite Big Bangs in time dimensions unavailable to human perception? It might also be, let me change the topic for a minute, talk about electromagnetism. It might be that electromagnetism is in part the alignment of space-time and magnetic materials such that it imparts motion to the surrounding primary space-time in a north-south direction or in a specific direction. It amplifies the local space-time pressure field, bringing the magnetic pieces together or forcing them apart, depending on their orientation to one another. I think we talked about 10, which is time asymmetry, and 9, baryon asymmetry, and 12, magnetism. Now, because pure time is set in motion by pure space, secondary space-time modules present a dynamic, constantly changing contour or envelope to the surrounding primary space-time field, which itself is constantly roiling. The void of the universe is composed of granular primary units, creating a field within which matter or secondary space-time exists. The primary space-time is the densest form of space-time. Here's an analogy. Imagine a large box filled with steel bowling balls. Okay, you have these big bowling balls on a box. It would be very heavy, of course. Now imagine that same box filled with steel BBs. It would be much heavier because the BBs fill up more space. In the primary space-time configuration, pure space is a minimal singularity imparting the least motion to pure time. Quantum fluctuation may be the granular interaction of primary space-time units, these tiny, tiny space-time units, combining their pure time motion, forming larger, non-durable secondary space-time and disintegrating instantly. So that takes care of number 3, quantum fluctuation. As previously noted, atoms and particles can vary in durability. It is posited that the surface of a particle or atom can occasionally present a contour that allows the surrounding primary space-time field to penetrate the presented surface and cause a change in the space-time, secondary space-time module or atom, such that the module decays into smaller secondary space-time units, emitting photons, electrons, neutrinos, and sometimes neutrons in the process. This phenomenon is most frequent in subatomic particles and very heavy atoms. Now here's an idea. Photons gradually dissipate all their motion to the primary space-time that envelops them. Hence, The cosmic microwave background originating at the Big Bang currently is measured at less than 3 degrees, and the dissipated motion creates more primary spacetime, expanding the universe. Now remember, the cosmic microwave background started extremely hot, and now it's down to 3 degrees above absolute zero. Where'd all that energy go? Could be that it becomes primary spacetime, expanding the universe. This effect is promulgated via the constant pressure of primary spacetime acting on secondary spacetime, constantly pressing in. Similarly, the neutrino can be conceived as a soliton with a more complex carrier signal than photons. The neutrino and sometimes the antineutrino is frequently involved, along with the electron and the photon, in decay processes of more complex secondary spacetime entities. Because of its more complex carrier signal, the envelope or contour of this soliton-like entity may oscillate or present differently as it travels through the primary field. Neutrino oscillation. It might be that neutrinos just have an envelope, a unique envelope, that as it tumbles through space-time, primary space-time, it presents differently. Electron, muon, tau neutrino. Could be. All right. So we've talked about 8 and 7. We talked about the expanding universe. We talked about neutrino oscillation. Regardless of the complexity or motion or carrier signal within the envelope, the neutrino envelope interacts weakly with the primary field and therefore travels at nearly the speed of light and appears nearly massless. Well known. While it is known that photons gradually lose energy or carrier frequency, there's no current literature about a similar phenomenon in neutrinos. Interesting. If neutrinos, which are much more numerous than photons, gradually lose motion and potentially create additional spacetime, this might contribute to the apparent acceleration of the universe. I wrestle with this because it's anti-intuitive, but there could be something here. Again, number 8, the expanding, accelerating universe. Here's another thought. As secondary spacetime absorbs motion, it shrinks in dimension and the surrounding time slows. Case in point, as particles in an accelerator speed up close to the speed of light, they tend to get heavier and flatten out. It is axiomatic that space-time slows with relative speed, as evidenced by satellites. The adjustments they have to make in the GPS satellites for the time difference. If, after passing through the event horizon or possibly the Cauchy horizon at the in a black hole, if particles approach the speed of light, which they do at these horizons, but if they achieve the speed of light at these horizons, it's conceivable that the particle becomes non-dimensional. In other words, it's getting heavier and flattened out. Conceivable that it becomes non-dimensional. A single point here with no dimensions at all, combining into a single point with all the other matter reputed to be at the center of the black hole. In this process, the pure time that accompanies the matter to the black hole may shed its motion to the pure space component of the secondary particle in passing through the horizon, and once again becomes time without motion. That is a now without a past or future. In other words, back to the same condition as at the Big Bang. A black hole may be a sphere of pure time surrounding a point of pure space. If one contemplates the notion that every possible form of space-time was created instantly, at the Big Bang, one possible form could have been black holes, which might help to account for the existence of supermassive black holes that puzzle physicists today. That's number 14. Now checked off. What do we got to go? We already did gravity. I think we have everything checked off. Of course, there is the issue of what happens to the information contained in the matter that falls into a black hole. This could be a concern that turns this entire conjecture into nonsense, or it might lend some support. I'm pondering this, but I haven't worked it out at the moment. I'm wondering, when a massive star collapses, creating a stupendous blast and heavy elements in the process, how much information is incorporated into the new elements and the energy sent into space? Another way to think of it, if energy equals mc squared, then energy and matter are forms of motion in space-time. If a black hole, this is a big if, but if a black hole is time without motion, it could be there is no information trapped inside. Weren't we all simple hydrogen at one time? Okay, this is the end of the conjecture. I'd like to recommend viewers who are interested to go to YouTube and watch a brief presentation by Richard Feynman entitled Feynman, Understanding versus Knowledge. Let me conclude saying nothing in this conjecture is meant to dispute the mathematics of quantum mechanics. Hence, the viewer may wish to invoke Occam's razor as far as interpretations go, deciding whether this is a simpler interpretation or merely a simplistic one. Thank you for your indulgence. I hope we checked off all the mysteries.